Okay, this is Organic Chemistry, Lesson 2, and today we're going to talk about naming and writing straight and branch chain hydrocarbons. So, to review, we said that the alkanes are saturated, and when we said saturated, we said that that meant that they contained all single bonds. And they're also called aliphatics. They're used for burning fuels, as fuels, propane, butane, etc. And they release energy when they are burned. And they also store a great deal of energy. They end in ane, and as I just said, saturated means all single bonds. They have the general formula CnH2n plus 2, which means that their hydrogens are 2 more than twice the amount of hydrogens. For example, we have pentane. Pent tells us that there's 5 carbons. So when we put that in the general formula, we have C5. H, 2 times 5 is 10, plus 2 is 12. So H12. So we've got 1, 2, 3, 4, 5 carbons, 2, 4, 6, 8, 10, 11, 12 hydrogens. Straightchain alkanes are also referred to as N-alkanes or N-pentane, or in this example, N-hexane, and the N simply just means normal. You don't have to write the N. If you write pentane, it's just pentane. If you see N-pentane, it's still just pentane. The general rule for naming straight-chain alkanes is that you use table P, which is your prefix table, meth, eth, prop, bute, pent, hex, hept, so on and so forth, and then you add the suffix ane. So it's really weird. You're going to see these a lot of different ways depending on the book. So if we're looking at butane, when we draw it two-dimensionally, so we just do this. So this is C4H10, which is butane, straight chain. This is drawn two-dimensionally, but is trying to represent a three-dimensional figure. So you've got 1, 2, 3, 4 carbons, and you still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Now, this you will rarely see, but each point represents a C. So this is a C, this is a C, this is a C, and this is a C. And then it's assumed that there's all H's off it. This is very old school. You will very rarely see that. This is what you'll see on the Regents exam and the way that I expect you to write it. And this is what you'll see in some textbooks, and you'll also it'll also look like this if you use the model kits, because the model kits can represent three-dimensional figures. Branched alkanes, meaning not straight. You don't have a straight continuous chain. You've got some smaller branches coming off of that continuous chain. How can you tell if it's branched? Well, if you can't run your finger along all of the carbons in one sweep, meaning you hit dead ends and you have to turn around and retrace some part of it, then we have some type of branch coming off of it. So right here, I can go from left to right, 1, 2, 3, but I can't get back to this carbon without retracing my steps. So this is considered a branched hydrocarbon. I could also go 1, 2, and down 3, but then I can't get to this one. Either way, these are going to have the same name. Okay, so as I was saying, I can number this chain 1, 2, 3, and that would be my parent chain. And here is my group. Now, if I have one CH3 group, that is a methyl group. And meth comes from 1C. If I had C2H5 coming off of this, so here's my CH3, okay? A C2H5 group would look like this. Here's C2H1, 2, 3, 4, 5. This is called an ethyl group. And there's one more that's called a propyl group, which is basically just C3H7. I don't think you'll see any of those, but I will write it down. So we go back and we name our parent chain, 1, 2, 3. Prefix for 3 is prop. It's all single bonds, so it's going to be a propane. And then off my second carbon, I have a methyl group. So it's like a street address. I have to say where it is. So this would be 2-methyl propane. Okay, some molecules may appear to be branched, but they are not. For instance, I can go 1, 2, 3, 4, 5. I can get to all these C's without retracing my steps. So this is just normal pentane. So what are the rules for naming branched hydrocarbons? Well, you locate the longest possible continuous parent chain, and any carbons coming off the chain are the branches. Number the carbons. This is really important. Number the carbons so that the parent chain, number the carbons so that the branches in the parent chain get the lowest possible number. So this may be from right to left or left to right. You're going to name the branches first, separately, in alphabetical order as per their prefix, along with the number of carbon that they are on. So the prefix is based on the number of carbons, table P, and then the YL ending. As I told you, CH3 is methyl, C2H5 is ethyl, C3H7 is propyl. Branches are named separately unless there are 2 of the same. If this is the case, lump them into the same branch name with number locations and add the appropriate prefix, di, tri, tetra, depending on how many carbons in the branch. And I'll give you an example of this. And lastly, the parent chain is stated last in the name. The number of carbons in the parent chain should agree with the prefix in the last word of the chemical name. Here we go. So, I have 1, 2, 3, 4, 5, 6, 7. Here is a CH3 group. I don't want to number this chain from left to right because my methyl group has the number 6. So I'm going to renumber this from right to left. So in this case, 1, 2, 3, 4, 5, 6, 7. Off the second carbon, I have a methyl group. So 2-methyl. Then I have 7 carbons in a straight chain. Prefix for 7 is hept, and it's all single bonds, so it ends in ane. Okay, let's see what we have here. I have a CH3 here. I have a CH3 here. And here I have a C2H5. So if I number from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I number from left to right, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. So numbering from right to left gives the branched groups a lower number. So what do I come to first? 1, 2, 3. 3, and that's an ethyl group. At the number 4 and the number 7, I have methyl groups. I name the locations. 4 comma, 7. Because they are the same, I have to use the prefix di. Dimethyl. There's 2 methyl groups at the 4 and 7, and 9 has the prefix non in table P, all single bonds, it ends in ane. All right, and this third example, and guys, you won't get ones that look like this on the test. So let's see what we have. So this is a C, this is a C, this is a C, 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 C. You've also got a CH3 here and a CH3 here. So in this one, it would be better to number from left to right, because this is going to be 1, 2, 3, 4, 5, 6, 7, 8. And my branch carbons are at 3 and 4. If I number from right to left, they'd be at 1, 2, 3, 4, 5, and 6. So where are they? So I have 3, comma 4. I have 2 methyl groups, so the prefix for 2 is di, so dimethyl. I have 8 in my chain. The prefix for 8, according to table P, is oct, and they're all single bonds, so octane. Again, you just need practice with this. Example 4. Now, I might say I want to start numbering up here. 1, 2, 3, 4, 5. So this would have a 5, 6. This would have a 6, 7. So that doesn't work. I could number it 1, 2. This would be here. 3, 4, 5, 6, 7. Or I could number it here. 1, 2. It doesn't really matter on this one, because if I number from here 1, 2, this branch is still at 2. If I number here 1, 2, this branch is still at 2. I probably intuitively would number this 1, 2, 3, 4, 5, 6, 7. So I've got this here, this methyl, and then I have an ethyl. So where's my methyl? So it's 2 methyl. And then I've got three ethyl, and it's 7, so my prefix for 7 is hept, and it's all single bonds, so it's ane. Let's look at this one. Now, here you have to be careful, because you might be apt to number this 1, but it's not. This is a bent chain. So 1, 2, 3, 4, 5, 6, 7, 8. That's my longest continuous chain. So I've got an ethyl at the 3, I have a methyl at the 4, and I have an ethyl at the 4. So let's name this. I have 3, 4. I have 2 ethyls, so it's going to be diethyl. And then at the 4, I have a methyl. And I have 8 carbons, so it's oct. And all single bonds, so it's ane. Here's another one. Let's see what they did here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's better to number from right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a methyl group at the 4. I have a methyl group at the 5. And I have an ethyl at the 6. Now, In this case, remember they said you have to name alphabetically. So technically, we can't do the 4,5-dimethyl first, okay? Because ethyl comes before methyl. So it's 6-ethyl, 4,5-dimethyl, and 10 is dec, and it's all single bonds, ane. So E comes before M, because we don't add the dimethyl till afterwards. Okay, now let's talk about unsaturated aliphatics. So these are alkenes. So now we have a hydrocarbon with a double bond. The general formula is CnH2n, which means there's twice as many hydrogens as carbons, and the formula ends in -ene. A normal alkene, N-alkene, the N tells you what carbon number the double bond is located at within the molecule. We only use N if the molecule has more than 3 carbons. So, prop is 3 carbons, so N equals 3. Cn, H2n, so my H's is 6. So I draw 3 carbons. Normal propene has the double bond on the first carbon. 1, 2, 3. Notice I can't have more than 4 bonds, remember, coming off a carbon. So this doesn't get 3 H's here because this is 2 bonds here. 1, 2, 3, 4. And then I have this middle C, 1, 2, 3, 4. And then my last C has the carbon and then the 3 H's. You only need to include a number for the multiple bond location if there is more than one location that it can possibly be. So in propene, the double bond can only be in one spot. You number the chain so that the lowest number gets the double bond, and then you add the suffix ene to the end of the name after you've determined the prefix using table P. So 1, 2, 3, 4, 5, or 1, 2. So we're going to number this from right to left, and we see that the double bond is between the second and third carbon. So we have to name where that is. So 2, and I have 5 carbons, that's the prefix for pent, and it has a double bond, so I use the ending ene. The 2 tells me that the double bond is between the second and the third carbon. On this one, I have 1, 2, 3, 4, 5. This is better to name from right to left to right. If I named it from right to left, it would be 1, 2, 3, 4, 5. So it would be 2 and 4 instead of 1 and 3. I don't think you're going to ever see one that has 2 double bonds in it, but 2 double bonds means it's a diene, so it's named a little bit differently. Okay, I still have to say where they are, so it's at the 1 comma, because it's between the 1 and the 2, 3, and this is 1, 2, 3, 4, 5. So this is penta, and this is a diene. So here the di goes in the middle of the name. Branched alkenes. We're going to do the same thing as we did with straight chain alkenes. The branch prefix comes first in the name. The parent chain comes last in the name, along with the number of where the double bond is located. So we're always going to name our branches first. So I have a double bond on the right, so I'm going to number this from right to left. 1, 2, 3, 4. I have methyl groups on the 2 and 3, so I'm going to name those first. 2, 3. There's 2 methyls, so it's going to be dimethyl. I have 4 carbons, so that's going to be bute. But I have to say where this double bond is. So this is going to be 1 bute and the double bond, so it has the ene. So 2,3 dimethyl 1 butene. Okay, we're almost done. Unsaturated aliphatics, which are alkenes, going to be just like alkynes, except for we've got a triple bond. And the formula is CnH2n-2, which means they have 2 less than double the carbons, and it ends in YNE. So, numbering 1, 2, 3. I have a triple bond on the first carbon. So I don't have to do this here, but I will. So 1, 2, 3, this is prop, 1 propyne. I could name this normal propyne. I don't have to even put a number. I can just call it propyne because there's only one place it can go. If you do 1 propyne, you still wouldn't be wrong, technically, on the regions. Over here, I've got 1, 2, 3, 4. No matter which way I number it, 1, 2, 3, 4, it's on the second carbon. So this is 2, 4 carbons is bute, and there's a triple bond, so it ends in YNE, 2-butyne. For straight chain alkynes, you just state the lowest carbon number where the triple bond is, then add the prefix YNE. Here's some examples. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Either way I number, it's on the third carbon, so this is 3, and there's 6, so it's hex, and it ends in YNE because it's a triple bond. Here I have 1, 2, 3, 4. It's on the first carbon, 1, 4 carbons is bute, triple bond, YNE. 2-pentyne. So I'm going to draw 5 C's. 1, 2, 3, 4, 5. I have the triple bond on the second carbon, and then I'm going to add my C's, my H's. Connect all these. So this has 1, 2, 3, 4. It's good. 1, 2, 3, 4. That's what it would look like. Let's see if I'm right, because remember the general formula is CnH2n-2. So if I have C5, H, 2 times 5 is 10 minus 2. So it would be C5, H, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's exactly what I have. Remember, you need to go back and make sure each carbon does not have more or less than 4 bonds. You need 4 bonds on every carbon. Example 4. 4-methyl 2-hexyne. So we always want to draw the parent chain first when we're drawing. So we're going to do hex, which is 6 carbons. 1, 2, 3, 4, 5, 6. They're telling us there's a triple bond on the second. 1, 2, 3. So that means the rest of these are singly bonded. So this one's going to have, oops. Let me just do that. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. This has got 1, 2, 3, 4. This has got 1, 2, 3, 4. 1, 2, 3, 4. Let's double check and see. Oh, we have a methyl group coming off the number 4. So we numbered this 1, 2, 3, 4, 5, 6. So they said that this was off the number 4. So we have a methyl group. Doesn't matter whether you put it on the top or the bottom, because you're drawing a three-dimensional object two-dimensionally. There we go. That's correct. Heptine, 5-heptine. So they're telling you 1, 2, 3, 4, 5-heptine. They want the triple bond here. Off the second and third. So 1, 2. Let's number these. 1, 2, 3, 4, 5. Off the second and third, you have a methyl group. You can have one on the top, one on the bottom, both on top, both on the bottom, doesn't matter. And then don't forget to put in the rest of your hydrogens. Everything's got to have 4 bonds. This one's got 1, 2, 3. We need another one here. This one's got 1, 2, 3. We need one here. This has got 4. This has got 3, so we need one there. Okay. Now, I know that this is very complicated, and the only way to get good at this, honestly, is to practice, practice, practice. And we will have plenty of that. Okay. Have a great night.